So hello, my name is Alistair MacKenzie and welcome to this first inaugural webinar brought to you by Predatar titled Meeting Patient Demand in a Cloud Native World. So what is this webinar series all about? Well, really it's this initial one is purely going to be a quick introduction into the world of containers and microservices. But as we go on with the series, we're going to be delving much deeper into the specific topic of data management and backup and recovery, which is designed for infrastructure professionals such as yourselves who are tasked with designing, architecting, building, and ultimately running very secure, very reliable backup and recovery infrastructures for this new cloud-native workload. So why have a webinar series purely for healthcare? Well, we think there are specific challenges associated with healthcare, or heightened challenges in this particular market, in this particular sector. Clearly over the last 20 years there's been very much an increasing digitization of data, electronic healthcare records, increasing use of telehealth and telemedicine. Is all about bringing this idea of a 360-degree view of patient information. More importantly, I think healthcare outcomes rely on better use of data, and so predictive analytics to enable to forecast trends and predict things that, without that extra level of artificial intelligence or machine learning, new apps are going to be created that just enable the constrained resources in these constrained times in order for them to continue to meet the demand associated with excellence in clinical and patient outcomes. With all of this as well, we've obviously got increased regulatory pressures. They aren't going away. HIPAA and personal healthcare information, PHI, is always prevalent. And as new technologies around networking in particular come in, such as 5G, this is going to help transfer these records around much more, so that we've got this idea of mobility of data. How are we going to enable that to happen, and what are the consequences of this increased mobility of data? Now, all of this data strategy, all of this use, we call it data offense, using data in a proactive, progressive way. Ultimately, all of this relies on having an always-on platform of secure and reliable data, protected from malicious threats, always available 24/7. Now, as we can see in this next slide, we're living in a vertical market, in an industry which is not without its challenges. You're having to do all of this transformation, this digital transformation, so to speak, against a backdrop of rising costs, more recently exacerbated by the pandemic. Revenues are clearly under pressure, and yet there's been an unprecedented demand for the services that the healthcare organizations provide, which clearly puts strain on that infrastructure, technology infrastructure architecture. So with these challenges constantly pushing and pulling at your bottom line, you are going to have to adapt. This is going to be a regular word, I think. The need to implement change very, very quickly and to be able to pivot your organization to meet these new market demands, these new market opportunities as well. So let's get into what this webinar is about, is this shift away from the traditional way of doing things. And one of the most traditional way of doing things was to build these great big monolithic software architectures that have been wedded to their underlying infrastructure, have been bolted on over time, over many years of development, which do amazing things, but unfortunately the ability to adapt and move them in a new direction is just too slow, can take too long. And what we need to do is move to something much, much nimbler. And looking at the next slide, what we're saying here is that your customers in the era of the smartphone and in the era of modern SaaS platforms in their everyday lives, their B2C, business to consumer lives, so to speak, their expectation is that all of this information, all of the services that you're going to provide need to be instantly accessible via apps 24/7. And they need to be constantly updated and improved on a regular basis, not dependent upon a test and dev cycle of testing and UAT development over many months or even years. So if you can set up your organization with the ability to continuously adapt to this changing marketplace, rather than be tethered to these systems that take months or years to pivot, for you now, or for healthcare, it's a competitive must. This newfound agility for the most leanest and the fastest moving healthcare organizations has helped them develop potentially life-saving applications such as the COVID-19 tracker in a very, very short space of time. And so to repeat, the ability to adapt and to pivot at pace has already taken hold in many other industries. Now we believe it's time for healthcare. So how can healthcare practitioners as a whole, ensure that the software that's in use, that software that's developed, is quick to adapt to this fast-changing world and more importantly, can be updated seamlessly without the need for lengthy outages that could impact the lives and safety of patients? What many organizations are doing, they're turning to this concept of microservices. In a nutshell, microservices allows your developers to break up the software into smaller and lightweight applications. The benefit of this is that each component can be updated, tested, and released quickly without the need to take down the whole application stack. This reduces downtime for your patients and the users, and whilst ensuring new features can be rolled out, bug fixes can also be fixes to bugs can be made as quickly and efficiently as possible. Moving at pace with traditional software, as we know, is hard. It requires multiple teams to collaborate and coordinate on things like critical dependencies, the underlying infrastructure, OS patching, developer libraries, etc. Moving on to the next slide, what we're talking about with microservices is that microservices flips all of this on its head, as your developers can then take all of those pieces and put them into a container. Once done, this container can be deployed almost anywhere, on-prem, in the cloud, moved to a different cloud, different geo, but it will continue to work with the other applications as it has been built to talk to. So it is with these new agile microservices that the criticality of all these dependent pieces move together, and it's the containers that make this possible. However, there is a downside, and the downside to containerized microservices is that your traditional infrastructure operations, your IT teams, will now have multiple smaller applications rather than just one big one to worry about. So the problem shifts from a lack of pace and agility and becomes more one of coordinating all of these different containers, potentially thousands of containers. And it is this where Kubernetes can help. At its most basic, Kubernetes, it's software designed to coordinate and orchestrate multiple containers, many containers. Just as an interesting aside, a fun fact, the name Kubernetes, where does it come from? Well, actually, Kubernetes, it's a Greek word, a word for the helmsman of a ship. And the reason this name was picked is that just like container ships in a large port, the job of Kubernetes is to understand what each container has in it, where it's going, and when. Think of it like a logbook or a manifest of everything that's going on in a very complicated scenario. But Kubernetes actually does much more than this. Kubernetes also helps you with scalability and resilience to stop your applications failing. For example, if a containerized application is hit with high levels of demand, Kubernetes can quickly help you scale up those additional instances of the container to spread the workload while adding more memory and storage to cope. And when demand tails off, Kubernetes, you simply scale everything back. Ultimately, what does this mean? This means you are only paying for the infrastructure you need when you need it. Very much like virtualization VMware did for the previous architecture era, Kubernetes does this in spades. So the savings that can be brought about through reduced administration and resources which are needed to develop and run your applications, the business benefit of this can become very compelling very quickly. Outside of just the cost savings, of course, one of the biggest benefits is the opportunity to shift shift resources and personnel to things that positively impact the customer and, what's most important, that patient experience, that patient outcome. And this is the potential game changer for healthcare, as it means you can use more of your resources to innovate and enhance a patient experience rather than just maintaining the status quo, keeping the lights on, so to speak. And businesses in other sectors are turning to new technology such as containers. They can see how it is this technology that allows them to innovate and push back against the challenge of shrinking budgets, increasing expectations, ever increasing expectations. So as we said, it's this thinking that's driving the surge in popularity of containers. And as the use of Kubernetes and containers builds, it's clearly highly likely, possible, even for a medium-sized business, that they could end up with thousands of containers in existence at any one time. And due to changes in user demand, some of these containers that we talked about may only exist for very small amounts of time. And so in this world of containers, it's going to be very transient. Ephemeral is another word you might hear. And the question that ultimately we're going to get to and explore further in this series of webinars is, how on earth do we protect this? How do we back it up? How do we do the housekeeping in this very extremely transient world? A container could be backed up 1 minute and then gone the next. In other words, as containers come in and out of existence, it is almost impossible to capture them for backup. This transient challenge that highlights how container workloads differ compared to your traditional workloads that we've been living in for the last 10 or 20 years. This concept of bare metal machines, SQL, Oracle, database servers, virtual machines, physical boxes. With container backup, it's not the actual containers per se that need backing up, but rather some of the underlying infrastructure, that log manifest, that cluster architecture, the underlying patient data clearly needs to be protected. But it's the coordination of all the tools, the intelligence that knows what's happening in this world of containers, that needs to be protected too. The good news is, over the last few years, the integration between containers and storage has improved significantly. Just like containers themselves, the storage used to hold the container can also be transient and could disappear as soon as the container disappears. And it's this type of transient storage is called stateless storage or persistent data. However, the containers that work with the important patient information will hold that data on permanent storage because you don't want to lose that data even if the containers cease to exist. This permanent storage is commonly referred to as stateful storage. It is this stateful data that needs protecting rather than the container itself. However, it is not just about backing up that stateful storage. The containers themselves might not merit backup consideration. You will need to protect the Kubernetes environment as a whole, because if this is lost, all your container orchestration, your knowledge about where everything is, will also vanish. And if this happens, just like the analogy of the port, the harbor port, you wouldn't know what was in each container or where it was going. So it's important to note that the complexity of backing up containers can vary based on your IT team's access to your Kubernetes environment. So for example, if you choose to host and run Kubernetes in-house, on-prem, whatever, your team will no doubt have all the required access that they need to perform housekeeping tasks such as backup and recovery, and of course the right tools to do so. However, if you choose to run this in third-party, hyperscale, public cloud, there's a high probability that your team will not necessarily have all of the access that they need to the underlying infrastructure, and this could compromise backups. And this is one of the things we're going to go into a lot more detail in subsequent webinars. So the choice comes down to one of cloud flexibility versus potentially losing some of that full control, that customization, the bespoke nature that you've been used to with on-premise infrastructure, losing control of the Kubernetes cluster and being reliant on a cloud provider to provide some of the basic form of data protection. So this may be one of the fundamental questions that you have to answer as you move to containers. And as I said, we'll go into more detail on this to help you with your decision-making process. But whichever route you choose, containers will open up a whole new way of working, allowing you to develop these new technologies, bringing them to market much quicker and much more effectively than ever before, whilst also tackling as we said in the earlier slides, some of those constraints, this push-pull tug of war between revenues under constraint, budget compromised, increasing patient demand. But let's look at ultimately backup and recovery from a back-end infrastructure point of view. This will also possibly need to change. And this is one of the reasons why we partner very closely with IBM and IBM Spectre Protect, and we know many of you who listen to this webinar will be users and practitioners around the IBM Spectre Protect portfolio. We choose it because we know that if we're not careful, as these changes come in, these new architectures come in, you could end up with a different type of backup product. Because not necessarily all of the old infrastructure is replaced, that still has to be maintained, that still has to be, the data on that has to be protected. And so it's very quickly you can end up with these silos of data. What we like about the Spectre Protect is the ability for it to provide total coverage across all of your workloads, both classic and modern and future focused. Whether it be traditional servers, power-based Unix servers, big Oracle databases, through to virtual machines, and now ultimately what we've been talking about more today, which is containers. The fact that all this can be done with one vendor builds on this message of efficiency and cost control that we've been talking about, and reducing and managing the stress associated with multiple technologies and vendors. But we're close to wrapping up, and we want to move on to questions, getting some insights from you, what you think, where in this journey you are. But if you want to learn more about Predatar, then please either get in touch, but stay tuned because there will be further webinars in this series as we go with you on this journey towards modernizing your infrastructure to solve some of the challenges associated with the healthcare industry as we see them today. But for now, I'll say thank you very much for listening. Thank you for your patience, and I'd like to turn it over to the vigilator for questions.